We are now ready to actually start doing the layout here. So what I have opened here, I've already got it open, but I'll show you what it is it's the Pcb Editor. So if you go to all programs and you go to your Cadence directory, it's going to be slightly different, but there is an Allegro products, and look, there's a Pcb Editor, and it's going to give you choices of which ones to pick. Just pick the first one, is fine. So this is my Pcb Editor. Now, the Pcb Editor lets you edit PCBs, but in addition, it also lets you create your footprints, your pad stacks, I'm sorry, not your pad stacks, but mounting holes and other things of that nature. We're not going to get into that in this course. We'll get into that later on, but we do have a footprint here, but what we want to do is we want to create a new board. And so I'm going to go up here and say Board Wizard. Now, before I do this, I want to make sure I navigate to the directory of where I saved that netlist. So for me, this was under Sample Circuits, PWM, and then Allegro. Remember, that's where we said it would generate those. So I'm going to save it in there. So I'm going to open that directory, and then I'm going to call this just PWM layout. And now as a wizard, it's going to step me through what we need to do. You can hit next on the first several things. So you can just hit next on all of these. I want to take a pause here. We're not going to change anything here. The units are mils. Mils is not the same thing as millimeters. Mils is actually thousandths of an inch. So 0.1 inches is actually 100 mils. 1,000 mils is equal to 1 inch. Alright, grid spacing, we don't need it at 1 mils. We'll do like maybe 20. And then etch layer count, we're actually only going to use a bottom layer, but we can just leave that at 2 for now. And then it'll say top and bottom here are routing. And then minimum line width. Now this is basically saying what's the smallest width of a trace. And in this case, we don't really need something horribly small. And in fact, if you were ever to actually etch this board and want to solder it, 40 is a good one to start with. Now, the minimum line to line spacing we can leave at 40. Minimum line to pad, I'm going to reduce this to 20 and this one to 20. That's just saying how much distance has to be in between pads and how much has to be in between a line and a pad. And then you always have to have a default via. Just put in via for your default via. We're not going to use vias, but you always have to have one. Then for some reason it always wants you to have a circular board, but we want a rectangular board. Now, this is not going to be the actual final dimensions of our board necessarily. When you get into advanced stuff, this you do want to be your final, but for now we're just going to go ahead and set this at 5,000 each, which means we're going to have 5 inches by 5 inches. Corner cutoff, that's where it's like this right here. It's trying to show you the corner cutoffs here, and that's for when you're trying to mount inside boxes, and like there might be screws that would be screwing the top in. Then we have these route keep-in distances. For now, we'll just leave those set at 0, and then we finish. And what this does is it generates a default thing here. Now I had to zoom out because of the resolution on the screen. You'll see that you should have this like little tan box here. You can use the mouse button to scroll in, zoom in and out, and if you use the little arrow keys here, well, maybe. Well, mine's not working. Usually you can use the arrow keys, or you can hold the middle. There we go. Hold the middle mouse button down, and you can use that to scroll around. Alright, but now what we have to do is actually import that netlist. We have to import all of those components. So I'm going to say import, but before I do that, I want to do a setup here and user preferences, because we have to make sure that it has the directories for the path names for the footprint. So we're going to go to user preferences. I'm going to expand the paths one and go to library here. And then I'm going to look at pad path. Now notice I have # pad path. That's just the default pad path directory. But then I've also added in the one that I'm using in Cadence here in my Dropbox folder. You want to make sure that you have one that is called, and I'll show you where it would be located. It'd be on the C drive, footprints. So you want to make sure C footprints is added there. If you don't have C footprints, it's not going to work properly. So I'm going to go ahead and take that out for now. Click OK. And then PSM path, I'm sorry, I said that wrong. On pad stacks, we don't want footprints. We want this to be, what you want is under the C directory. And what we want is pad stacks. So you're going to want C pad stacks located there. Now, I have something different. I'm going to take that away because I don't want it to have any kind of confusion between which directory to look at. But you want to make sure C pad stacks is added in there. Then you're going to go to the PSM path, do a similar thing, but in this case we want to make sure that under the C directory that we have the footprints one. So you want to have C footprints located there. So before you do anything else on this, you want to make sure those things are there. Now again, I don't want those for mine, so I'm going to take that away. And then you would click on Apply, or you click on OK, and that's fine. That's basically setting the directories so it knows where to look for the footprints. Now we're ready to import the netlist. So you go to Import Netlist. You have to tell what type. Well, we did this as capture. And then we need to tell it where to look for it. Now, we don't have to in this case because we've saved it in the same directory as where the netlist is located, but it's in that Allegro directory. Notice sample circuits PWM Allegro. So it's in your Allegro directory, whichever one that is. Now I'm going to go to import, and hopefully we did this correct, or I'll get some errors. It says processing successfully completed. If you get an error, that means you've missed a footprint name, you've typed in a footprint name wrong, and it'll give you a log file to tell you where your error is. But we got no errors, so that means everything was imported successfully. We're now ready to place components. So we go to Place, we're going to go Components Manually, and then I have two monitors here, which I don't have it listed here, but it's not listing any of my things here. Just a second, let me try this again. Place components manually. Let me import again here. Something's not right. Yeah, I just did another import. I don't know why that was happening, but notice I didn't have all of these before. I do now. I don't know what was going on there, but I just re-imported the netlist, as you could see. But then I just selected the checkbox, and I'm starting to go ahead, and you can see there's these little component symbols now, and I'm going to start just placing them. Now, for now, I'm not necessarily going to worry where they are. I'm just going to place them. And you'll notice these little blue wires. We'll get to those here in a second, but right now I'm just going to place everything here. So everything's placed. I'm going to close this, and it's a good idea to save this. For some reason this program likes to crash. Now the one thing I'm going to do here is I'm going to open up my circuit diagram here. I'm actually going to move it into my other window here because the next step here is what's called de-rat nesting. Now this is what's called a rat's nest. Blue wires are showing where all the connections are need to be made. Now if I zoom in, you can see R5. You can see that it's got these little designations for these components. Now what we need to do is we want to unrat's nest this, and we want to move things around. Now I like to bring up this place components. That makes it the easiest to move things around, and I would just click on it and I can move it around, and notice how the rat's nest things will change. I can rotate it, you know, so that these lines, and we want to unrat's nest this as much as possible. And then if you right click, you can say done. There's this oops or a cancel. I love the oops. The oops undoes the last thing that you did. So we want to move these around. Now you want to move them around though in a way that makes sense. Like for instance, this is the potentiometer. And notice there's this little rectangle here. That's the knob of the potentiometer. So I want to rotate that for sure, and I want to put it what would be kind of maybe next to an edge of the board here, because I want it to be easy to use. I don't want to have this in the middle of the board, because then that would be hard to use the potentiometer. The next thing I want to do is place this jumper 1 here, which is my power supply. So I'm going to place that somewhere. You don't have to put it on the edge of the board, but I'm going to put it towards the edge here. And there, I can already see there's a mistake here for that jumper one. It's not connecting correctly. Let me go back and check my cadence file. I'm not quite sure why it's doing that. Because what it's saying is that pins 1 and 2 are connected, which is not good, because you'd be shorting out your power supply here. So hold on one second, I'll pause the video. Okay, I found where my mistake is, and I'll show you how to fix it here. Notice I've got a ground here times to VCC, so ground was connected to VCC, so that's where the problem was. So that was a mistake that I hadn't noticed in it. Now, it's not the end of the world. You just have to then, once I deleted that ground, I need to go to create Netlist again, and then I create a new Netlist, and then I'm going to move that away. Now, I don't even have to worry about replacing that. All I'm going to do is import the Netlist again, and notice that it changed where all those wires were going. So I don't even have to replace all the components here. Okay, but now we're going to go ahead and finish de-rats nesting this. And so I'm going to just again open this place components manually screen just to make things easier to move around. And so again, we're going to put this power. Actually, you know what we're going to do here is I'm going to put this op amp close to the PWM. So then I'm going to move this right here, rotate this around, and I'm not necessarily worrying about this being great. I'm just doing and then I'll move this down here, maybe rotate this a little bit, rotate this, and then you might want to say, where do you put your diode? Well, that's kind of, almost user preference as far as where the diode is going to be. I'm just going to put it right here. I'm going to go ahead and rotate that. And then I'm going to go ahead and move this, put this kind of right here, and then put this one right here, and then note where some of these capacitors are. So you kind of have to play around with this a little bit. And you want to try, and basically, it's basically like de-rats nesting it, or you can almost look at it as doing spaghetti kind of map kind of idea here. So rotate this. Rotate this. So that's right there. Okay, this resistor, maybe I'll put here, but I'll rotate it. And the power I'm going to put over here. And this resistor here. Maybe rotate it again. And I don't know if this is a perfect one as far as de-rats nesting it. I'm just working on this a little bit. And this you can actually spend quite a bit of time working on to get it to be correct. So put it like that. And when I say get it to be correct, have it the fewest number of things crossing. So I'm just going to call this good for now. And, is this perfect? I don't know. I don't really care at this point. But you want to keep components together. You don't want to take up a lot of the circuit board. So we're going to do this and have it be here like this for now. So I'm going to save this. Yes, I want to overwrite. And then we'll go ahead and end this video here. The next video we'll take up here, and we'll go ahead and put all the traces down.